Here are the few important problems on the irrotational vectors, and this also includes the scalar potential function. So here we shall see the first problem. Show that the vectors x cube minus yz of I bar plus y square minus zx of j bar plus z square minus xy of k bar is irrotational and find its scalar potential function. So here we have to find out we have to prove that this vector is irrotational. Nothing but curl of the vector. For example, if this vector is f bar, then curl of the vector f bar is equals to 0. We have to prove this. Then after we have to find its scalar potential function. Nothing but we have to find out the pi. So here let f bar is equals to the vector x cube minus yz of I bar plus y square minus zx of j bar plus z square minus xy of k bar. So from this, when we compare with the equation f bar is equals to f1 I bar plus f2 j bar plus f3 k bar. Here f1 coefficient is x cube minus yz. That is the I bar coefficient, and j bar coefficient is y square minus zx, which is f2, and f3 is the k bar coefficient, that is x square minus xy. So we got the f1, f2, f3 values. Then curl of the vector f bar is equals to determinant of I bar, j bar and k bar, that is dou by dou x, dou by dou y and dou by dou z. So here the f1, f2, f3 values are x cube minus yz, y square minus zx and z square minus xy. So we have to find out the determinant of this. When we find the determinant, that is I bar of dou by dou y into x square minus xy minus dou by dou x of y square minus zx, and minus j bar of dou by dou x of z square minus xy and dou by dou z of x cube minus yz, and then plus k bar of dou by dou x of y square minus zx and minus dou by dou y of z cube x cube minus yz. So we have to simplify this now. So that equals to I bar of, here the differentiation of z square becomes 0, and here minus x is constant and y differentiation is 1. And here y square differentiation is constant and minus zx minus x is constant. So minus of minus x. We get I bar of minus x minus of minus x. And here minus j bar of, here z square differentiation becomes 0, and here minus xy minus y is constant. So we get here minus y, and x differentiation with respect to x is 1. Minus dou by dou z of x cube minus yz. X cube differentiation is 0, and here minus y is constant. So we get minus y minus of minus y. Then here plus k bar of y square differentiation is 0, and in minus zx minus z is constant. So we get here minus z, and minus here we get here y is constant and minus z. So we get minus z minus of minus z. So when you simplify that, we get I bar of minus x minus into minus is plus x, minus j bar of minus y plus y, and plus k bar of minus z plus z. So we get here the coefficient of I bar is 0, and minus j bar is also 0, and k bar coefficient is also 0. So overall vector is 0. So we got the curl f bar as 0. Therefore we can say that f bar it is a irrotational vector. Now we have to find out its scalar potential function. So we know that if we have seen in the note point, that is curl of grade pi is equals to 0 when f is equals to grade pi. For example, if we take a vector f bar which is a grade pi, then the curl of that vector f bar is equals to 0. So this can also be written as curl f bar is equals to 0. F bar nothing but which is grade pi. So here we got the curl f bar as 0. It is nothing but f bar is equals to del pi, we can write it. So that is, this is f bar vector, that is x cube minus yz of I bar plus y square minus zx of j bar plus z square minus xy of k bar, that equals to del pi. Del pi nothing but, we know the formula, I bar dou pi by dou x plus j bar dou pi by dou y plus k bar dou pi by dou z, which is del pi. Now we have to here with the coefficients of I bar, j bar and k bar we have to check on because these two equations are equal, then their coefficients are also equal. So from these two we can say that I bar coefficients are equal, that is dou pi by dou x is equals to x cube minus yz. So we get here dou pi by dou x is equals to x cube minus yz. Similarly, j bar coefficients is also same. So dou pi by dou y is equals to y square minus zx, and dou pi by dou z is equals to z square minus xy, which is a k by coefficients. Now we got these equations. Now we have to integrate it on the both sides. So when we do the integration and the differentiation will be cancelled. So that is, here we are integrating it on the both sides. So integration of dou pi by dou x is equals to integration of x cube minus yz of dx, and integration of dou pi by dou y is equals to integration of y square minus zx of d pi. Then integration of dou pi by dou x is dou z is equals to integration of x square minus xy z square minus xy of dz. So now here we have to here the integration and the differentiation gets cancelled because those are inverse. Then we get pi is equals to, here the integration of x cube with respect to x is x power 4 by 4, and here minus yz is constant, and so we can write outside of the integration, and integration of 1 with respect to x becomes x. So x is multiplied with minus y and z, so we get minus x into yz. And here also the same integration and differentiation get cancelled. So pi is equals to y square differentiation with respect to integration with respect to y is y cube by 3, and here minus z is zx is constant, and integration of 1 with respect to y is y. So we get y cube by 3 minus x into yz, and here also integration and differentiation gets cancelled. So pi is equals to z cube by 3, since we are integrating with respect to z, and here minus xy is constant, and 1 integration with respect to z is z. So we get z cube by 3 minus x into yz. So we got the pi here. So to find out the total scalar potential function, that is pi, we have to add all these. So we get x power 4 by 4 minus x into yz plus y cube by 3 minus x into yz plus z cube by 3 minus x into yz. So first all write the cube terms and power 4 terms, that is x power 4 by 4 plus y cube by 3 and z plus z cube by 3. So minus xyz and minus xyz, which is minus 3 into xyz. So this is the scalar potential function, which is nothing but pi. Here is one more problem which is very similar to it. Find whether the function f bar is equals to x cube minus y cube of I bar plus y cube minus 3x of j bar plus z square minus 2y of k bar is irrotational, and hence find scalar potential function corresponding to it. Here also the same, f bar is given, we have to prove that it is irrotational vector. Nothing but we have to find out the curl of the vector f bar. If it is equals to 0, then it is irrotational, and we should also find out the scalar potential function, nothing but pi. So when it is a when it is a curl, the curl of the vector f bar is 0, then only we can find out the scalar potential function. So first we have to check whether it is irrotational or not. So to find that, we have to find out the curl f bar. So f bar is equals to x cube minus y cube of I bar plus y cube minus 3x of j bar plus z square minus 2y of k bar, which is a f bar vector. So when we compare with the equation, f bar is equals to f1 I bar plus f2 j bar plus f3 k bar. F1 values we get, F1, F2, F3 values we get here. That is a I bar coefficient and j bar coefficient and the k bar coefficient. So we get F1 is equals to x cube minus y cube, and F2 as y cube minus 3x, and F3 as z square minus 2 into y. Now we have to find out the curl of the vector f bar. That equals to determinant of I bar, j bar and k bar, dou by dou x, dou by dou y and dou by dou z. Here F1, F2, F3 values. Those are x cube minus y cube minus 3x and z square minus 2 into y. Now find out the determinant of this. So I bar of, deleting this row and column, we get dou by dou y of z square minus 2 into y minus dou by dou z of y cube minus 3 into x, and minus j bar of dou by dou x of z square minus 2 into y and minus dou by dou z of x cube minus y cube, and similarly plus k bar of dou by dou x of y cube minus 3x minus dou by dou y of x cube minus 3y cube. So here the differentiation I bar of z square differentiation is 0, and minus 2y differentiation with respect to y is minus 2, and minus y cube differentiation with respect to z is 0, and minus 3x differentiation with respect to z is also 0. So we get minus 0. Minus j bar of z square minus 2 into y. There is no x term in this. So whole differentiation becomes 0. Minus x cube minus y cube. Here also there is no z variable in this term. Since we are differentiating with respect to z, so its differentiation becomes 0. So we get minus 0. Plus k bar of y cube differentiation is 0. Minus 3x differentiation with respect to x is minus 3. Minus of here y cube x cube differentiation is 0 and minus y cube differentiation is minus 3 into y square. So here we get minus 2 I bar minus 0 j bar plus minus 3 minus into minus plus 3 into y square of k bar. So here we got one vector, but f bar vector, the f bar vector is not irrotational because the curl of the vector f bar is not 0. So curl f bar is not equals to 0, so it is not irrotational. So we cannot find out the scalar potential function. So here is the third problem, that is prove that r bar is a position vector of any point in a space, then r power n r bar is irrotational. Show that curl r power n r bar is equals to 0. So the question can be asked in the way, or it can also be asked in this way also. So here for the first question, r bar is a position vector. So when r bar is given, we have to take it as xi bar plus yj bar plus zk bar. So we have to prove that r power n r bar is irrotational. Nothing but the curl of the vector. For example, if we assume r power n r bar as f bar vector, then the curl f bar vector is 0. We have to prove that. Then we can say that it is irrotational. Or the question can be asked as show that curl r power n r bar is equals to 0. It means they are asking us to prove it is a irrotational vector. So for both the questions, the answer is same. Let's see the answer here. So let r bar is equals to xi bar plus yj bar plus zk bar. Then r is equals to mod r bar is equals to root x square plus y square plus z square. So this is a modulus of r bar. That is root of x square plus y square plus z square, and this can also be written as r. So when we square on the both sides, we get r square is equals to, here the square will and root will be cancelled. So we get x square plus y square plus z square. Now we have to differentiate with respect to x. So when we differentiate with respect to x, we get 2r, dou r by dou x is equals to 2x. So on the left side, differentiation of r square is 2r. But as we are differentiating with respect to x, so the inside function, that is r, also gets differentiated with respect to x. So we get dou r by dou x. On the right hand side, y square plus z square differentiation becomes 0 and x square differentiation is 2x. So 2 will be cancelled on the both sides. So dou r by dou x is equals to x by r. So this is the dou r by dou x value. When we differentiate with respect to x, we get this. Similarly, when we differentiate with respect to y, we also get the same, dou r by dou y is equals to y by r. And when we differentiate with respect to z, we get dou r by dou z is equals to z by r. Now the vector is given as r power n r bar. So r power n into r bar, that equals to r power n of r bar nothing but xi bar plus yj bar plus zk bar. So now this r power n is multiplied with each of the term. So we get x into r power n I bar plus y into r power n j bar plus z into r power n k bar. Now we have to find out the curl of this vector r power n r bar. So we if this curl r power n r bar is equals to 0, then we can say that it is irrotational. So anyhow it will be equal to 0, because in question they asked to find prove that it is irrotational. So here we have to find out the determinant I bar, j bar and k bar, dou by dou x, dou by dou y and dou by dou z, and if r1, r2, r3 vectors. For example, if you assume this total vector as r bar vector. So we get this x r power n, y into r power n and z into r power n. So we get here I bar into dou by dou y of z into r power n minus dou by dou z of y into r power n plus j bar of dou by dou x of z into r power n, that is by deleting this row and column, and here minus dou by dou z of x into r power n plus k bar vector of dou by dou z of y into r power n and dou by dou y of x into r power n. And then here we have to differentiate with respect to y here. So I bar of z is a constant. So here we have to apply the u into v method. Z is a one variable and r power n is another variable. So we have to apply the uv method. That is dou by dou x of dy dx of u into v can be written as u v dash plus v u dash. Here u dash v dash nothing but differentiation of that vector. So we get z into r power n. Here first we are taking z as constant. So that z into r power n differentiation, that is n into r power n minus 1, and since we are differentiating with respect to y, so we get dou r by dou y. Then plus u v dash completed. So we have to find out v u dash, that is second variable. Constant will be, second variable is constant, and differentiation of z with respect to y. So we get r power n dou by dou y of x. So first term differentiation is completed. Now the second term minus of y into r power n differentiation with respect to z. So here first y is constant. So write y, and r power n differentiation with respect to z is n into r power n minus 1 dou by z, and plus power n is constant, differentiation with respect to z, r power n dou by dou z of y. Similarly with the this is first I bar coefficient, and next is j coefficient. So the j bar coefficient also differentiation will be same, that is minus j bar of z is constant, r power n differentiation is n into r power n minus 1 dou r by dou x, plus r power n is constant and differentiation of z with respect to x, that is r power n dou by dou x of z, and the second term minus of x into r power n differentiation with respect to z. So x is constant, so x into r power n differentiation is n into r power n minus 1 dou r by dou z, and plus r power n dou by dou z of x. Then here, and the k bar vector plus k bar of y into r power n, that is differentiation with respect to x, we get y into n r power n minus 1 dou r by dou x, plus r power n is constant, r power n dou by dou x of y, and minus of here the second term, that is x is constant and r power n differentiation n into r power n minus 1 dou r by dou y, plus next r power n is constant and differentiation of x with respect to y. So r power n dou by dou y of x. Now here we have to substitute the dou r by dou y, dou r by dou x, and dou r by dou x, dou r by dou z, and dou r by dou x, and dou r by dou y values from these three equations. And before that you have to multiply this minus inside the bracket here. It is multiplied with the two of the terms, and in the second j bar coefficient also this minus multiplies with the both of the terms. But here the differentiation of r power n and dou z by dou x. So here z is another variable, it doesn't contains the y variable, so its differentiation becomes 0, and that 0 multiplies with r power n. So this whole term becomes 0. And here also r power n y differentiation with respect to z is also 0, and that multiplies with r power n, so whole differentiation becomes 0. And here also differentiation of z with respect to x is also 0, and differentiation of x with respect to z is 0, and differentiation of y with respect to 0, and similarly x differentiation with respect to y is also 0. So here the 6 terms becomes 0. Then you need to bother about this, and this minus is multiplied with each of the term here, and we have to substitute the values of dou r by dou y, dou r by dou z, dou r by dou x, dou r by dou z, and dou r by dou x, dou r by dou y, and we have to simplify it further. So after substituting the values, we get I bar of z into r power n minus 1 into y by r plus 0 minus of y into n into r power n minus 1 of z by r plus 0. And here minus j bar of z into n r power n minus 1 of x by r plus 0 minus of x into n into r power n minus 1 of j by r, z by r plus 0 plus k bar of y into n r power n minus 1 of x by r plus 0 minus of x into n into r power n minus 1 of y by r. So that equals to I bar of here z into n r power n minus 1 y by r, and this minus multiplies with inside. So we get minus y into n r power n minus 1 z by r, and here also the same minus j bar of z into n r power n minus 1 x by r minus is multiplied inside, so x into n r power n minus 1 z by r. Similarly, plus k bar of y into n r power n minus 1 x by r minus x into n r power n minus 1 y by r. Now all the terms are similar because z into y or y into z is both are same. So plus term and the minus term. So this value becomes 0, and similarly here also z into x and x into z, y into x and x into y. So its value becomes 0. Then we get whole value will be 0. So here we get 0 I bar minus 0 j bar plus 0 k bar. So that equals to 0. This is the curl r power n r bar. So curl r power n r bar we got it as 0. And then here the final question. If f of r is differentiable, show that curl r bar f of r is equals to 0, where r bar is equals to x into I bar plus y into j bar plus z into k bar. So given that f of r is differentiable, and we have to prove that curl r bar f of r is equals to 0. It is somewhat similar as the previous question, and r bar vector is given here. And then modulus of r bar, that is r bar mod r bar is equal to root x square plus y square plus z square, which can also be written as r. Squaring on both sides, r square is equals to x square plus y square plus z square. And we have to differentiate with respect to x, y and z. So we get dou r by dou x as x by r, dou r by dou r, and dou r by dou z as z by r. First we have to find out r bar f of r before finding out the curl of it. So r bar of r is equals to r bar vector nothing but xi bar plus yj bar plus zk bar of f of r. So now this f of r is multiplied with each of the terms inside. So we get x into f of r I bar plus y into f of r j bar plus z into f of r k bar. So this is the r bar f of r. Now we have to find out the curl of this vector r bar f of r. So from this we will take the coefficients of I bar and j bar and k bar. We find out the determinant. So curl r bar f of r is equals to determinant of I bar, j bar and k bar, dou by dou x, dou by dou y and dou by dou z, x into f of r, y into f of r and z into f of r. Now the determinant of this I bar of dou by dou y of z into f of r and minus dou by dou z of y into f of r, minus j bar of dou by dou x of z into f of r minus dou by dou z of x into f of r, plus k bar of dou by dou x of y into f of r minus dou by dou y of x into f of r. So now we have to differentiate this. So I bar of, here also the same differentiation as we did like in the previous problem. Here the first z will be constant. Here also we should apply the UV method. So first z is constant and differentiation of f of r is f dash of r, and the inside function r is also differentiated. So we get dou r by dou y plus the second function into f of r into differentiation of xz with respect to y. So dou by dou y of z minus the second term. So that is y into differentiation of f of r, that is f dash of r and dou r by dou z plus f of r into differentiation of y with respect to z. So that is dou y by dou z. And also the next j bar coefficient, that is minus j bar of z is constant and f dash of r, with that is f of r differentiation is f dash of r into dou r by dou x plus f of r into dou z by dou x minus of x into f dash of r into dou r by dou z plus f dash of r into differentiation of x with respect to z, that is dou x by dou z. Now the k bar coefficient, that is plus k bar of y into f dash of r into dou r by dou x plus f dash of r f of r into differentiation of y with respect to x, that is dou y by dou x, then minus of x into f dash of r into dou r by dou y plus f of r into differentiation of x with respect to y, that is dou x by dou y. So now here that equals to I bar of z into f dash of r, here dou r by dou y value is y by r, plus here the differentiation of z with respect to y is 0, since there is no y variable in this. So in 0 into f of r is 0, so this whole term becomes 0, and in this term also we are differentiating with respect to z of y, so its differentiation also becomes 0, and here dou z by dou x is also 0 and dou x by dou z is also 0 and dou y by dou x is 0 and dou x by dou y is also 0, and so we get plus 0 minus of y into f dash of r, dou r by dou z value is z by r plus 0, and here the j bar coefficient minus j bar of z into f dash of r, dou r by dou y value is x by r plus 0 minus of x into f dash of r, dou r by dou z value is z by r plus this value is 0, and then here plus k bar of y into f dash of r, dou r by dou x value is x by r plus the value of this is 0 minus of x into f dash of r, dou r by dou y value is y by r plus 0. Now multiply this minus inside this, we get I bar of z into f dash of r y by r minus y into f dash of r z by r minus j bar of z into f dash of r x by r minus x into f dash of r into z by r, and here plus k bar of y into f dash of r x by r minus x into f dash of r into y by r. So here z into y is yz and here y into z is also yz. So the both terms are similar, and then it is a difference of plus and minus. So this value becomes 0, and here also the value becomes 0, here also the value is 0. So that we get it as 0 I bar minus 0 j bar plus 0 k bar, which is nothing but 0. So therefore the curl of the vector r bar f of r is equals to 0, then hence it is proved that is it is irrotational.